Hello everyone, and welcome back to Band 7101 Business Analytics. In this module, we're going to discuss neural networks and then see how to apply neural networks in Python. The learning objectives for this module are as follows. So after this module, you should be able to build a classification model using a neural network in Python and interpret the results of neural network classification analysis in Python. We have already discussed the basics of data mining, that we are looking for patterns in data. We've also visited clustering and introduced the concept of classification. The neural network technique falls under the umbrella of classification. It is a supervised learning technique where you are going to attempt to classify different data points or records that you have according to different categories that you have. So your algorithm will learn about what makes a particular record fall into a specific category. In this case, we're going to look at the flower data set of the iris flower and see if we can predict accurately based on petals and sepals, which are parts of the flower, which type of iris that flower is. As a reminder, the primary source for accuracy estimation in classification is the confusion matrix. So we calculate the overall accuracy by adding together the true positive count and the true negative count and dividing that by the sum of the true positive, true negative, false positive, and false negative count. Two additional concepts worth discussing here are that of precision and recall. To calculate the precision, we divide the number of true positives by the sum of the true positives and the false positives. This tells us overall how many of the selected items that we have are relevant. To calculate recall, we divide the true positives by the sum of the true positives and the false negatives, and this tells us how many relevant items are selected. These are both measures of relevance for the model that you generate. We also discussed the concept of splitting the data into testing and training. In the case of neural networks, we're actually going to advance this a little bit into three parts. So we'll divide the data into a training set, upon which we will train the model, a validation set, which we will validate the model with, and finally a testing set from which we can develop our confusion matrix. So what is a neural network? Neural networks are designed to operate the way that the human brain operates when it is learning. So a neural network has three different layers: the input layer, the processing layer, and the output layer. You can have as many processing layers as you like, depending upon how deep learning you want to do. But essentially, each of the nodes in these layers serves as an artificial neuron, similar to the neurons in the human brain, that learns based on the data that it is processing. It is still difficult to say exactly what goes on inside the processing layer of a neural network. However, what we do know is that regardless of being able to see inside of the processing that takes place, we can still generate highly robust classification models using this technique. So again, think of it like we're mimicking the learning process of the human brain using nodes that represent artificial neurons. We send data in, we don't know exactly what happens during the processing, and then we get some information out. There's a very famous data set that is often used in neural network discussions, and that is the iris flower example. Here we have the three types of irises, so the iris setosa, the iris versicolor, and the iris virginica. These are going to be our target. So what we want to know is based on the petal length and width and the sepal length and width of the flower, can we accurately classify a new record based on these measurements as one of these three classes, and can we do it correctly? So this data set is composed of records of petal length, petal width, sepal length, sepal width, and the indication of which class that flower belongs to. Here is a snapshot of the data. So again, we're working with classification model, that of the neural network. Our target is the type of flower or the species or the class, however you want to think of it. And the data that we have in each record are the length and width of the sepal, so that meaning this part of the flower, as well as the length and width of the petal, so this part of the flower. This has been a very brief introduction to the concept of the neural network. We're now going to go ahead and move over to Python in a tool called Google Colab. So similar to a Jupyter Notebook, Google provides a web browser-based method of running Python code. This allows us to jump directly into the code without having to put anything on our machine. So at this point, we're going to head over to Blackboard and take a look at that tutorial. Just so you're aware, this tutorial is going to be based off of this Towards Data Science tutorial reference here. If we open it up, we can see the author gives an explanation of how neural networks work. This is a more in-depth article than our brief introduction and is perhaps geared more toward computer scientists. However, it is relevant for data analysts and data scientists as well. So you can feel free to read through that at your convenience. He then goes on to introduce the dataset, just as we already have. So the iris flower dataset. Here's the snapshot that I pulled of the different lengths and widths of the petals and the sepals, as well as the species. Here he's provided a scatter plot of the petal width by the sepal width, and this plot actually gives us some interesting information. We can see that there is some correlation between these two values, and we actually have some clusters here that we can see in the data, so that these are the iris setosa, these are the iris versicolor, and these are the iris virginica. So this exploratory look at correlation indicates to us that perhaps we will get something out of a classifier, that it's worth taking a look at classifying by these values in order to predict what species we have. The first thing we need to do is get our environment up and running. So if you head back to Blackboard, what we're going to do is open up the Google Colab tool, and we're going to select a new notebook. You can see I was already working on this. So choose new notebook, and what it's going to do is create an environment for you where you can write Python code and save it directly in the browser. So I'm going to go ahead and save this as just plain old iris. IPYNB is the file extension. You can save this code in your drive if you are logged into Google. You can also save it to GitHub if you have a GitHub account. I have also changed some settings in the editor for readability. You can change those as well here. So I've changed it to dark mode because that's easier on my eyes. I've increased the font size some so that it's easier for me to teach. And you can make other adjustments as well. So I'm going to be showing the line numbers and the indentation guide. So in Python, indentation is extremely important. You don't need to have any Python experience previously in order to run this tutorial. I'm going to just make it very simple and clear as to what you're doing. The important thing is that you're able to interpret the results and at least have some idea of how the data is being processed. I'm going to go ahead and save these. And so what we're going to do is we're going to adapt the code provided in this tutorial over here so that we can run a neural network classifier on the iris dataset and interpret the results. Just so you can see how this works, you can in fact just write Python code directly in here. So for example, I can write print hello world. In order to run the code, I'm just going to hit this play button right here, and you'll see that it does print hello world below. So again, no experience needed in Python. I thought it would be interesting to give you a little bit of experience with a tool like this if you hadn't had it before. And of course, if you are experienced with Python, you can feel free to use any tool that you like. You just may have to import packages as necessary through your console. So he breaks this up into first importing different files and different packages required for doing the processing. So you can see here he's getting the iris dataset from that UCI dataset that we've talked about so much. So it's actually referencing this website here. Pandas is a very common framework used in Python for data analytics, as well as the sklearn tools. I'm simply going to highlight all of this and copy it over. I'm going to get rid of this and just copy it right over. So you can see at the top, we're just importing some libraries. Here we get the dataset from UCI. Here we actually read in the dataset. And then we do some pre-processing in order to make our lives easier while we're interpreting. So here, for example, we rename the columns. We wrap the output values to integers. And then we're actually going to print the data frame. So we'll take a look at that. We'll get to this in just a minute. But at this point, I'm going to go ahead and just run it and see what we get. I'm actually going to alter this code here to actually print the data frame. So I'm going to wrap it in parentheses and say print. And adding that little bit, you can see that we have adjusted the column names. And we have 150 rows here. So we have 150 samples of flowers with different petal and sepal lengths and widths, as well as a classification of species. So it looks like species has been defined as 0, 1, or 2. We'll see if he recodes that as we move along. So that's everything up to this point. Next, remember we need training and testing at the very least. So here we're defining the input and target variables for training and testing, and we're going to split the data into two parts there. So he actually decides to just do training and testing and set that testing data size as 20% of the data. Heading back over to the tutorial, I'm going to go ahead and scroll down. Now he does this step by step. I might consider cleaning this up and bringing all the imports up to the top, but we're not going to do that here since this is not a Python class. This next part, we are going to define the neural network class that's going to be used. So this is all of the functions required in order to create and run the neural network. So I'm going to go ahead and copy this over and then we'll talk about it a little bit. When you copy and paste it, go ahead and just put it on line 28. So move your cursor down and you can paste it right there. So NumPy is another very commonly used library for dealing with data analytics in Python. Here we're defining an entire class in order for us to use a neural network. So you can see we have a random number generator involved here. That's going to be involved in that processing layer. This is some of the underlying math that goes into that. And then this last bit here, we're going to predict the new records in the testing set. Here we have the training set, so 80 examples consisting of 4 input values and 1 output value. This function here is where we actually train the neural network using the training set. We've set the number of iterations to 1000. We're going to print the synaptic weights after the training here, and then transform the results into a format that we can easily read. So let's go ahead and run the code up to this point. So we're still printing out this frame up here, we don't need to, and then we have these synaptic weights. So these weights are what is used inside the neural network to actually do the learning. You can see that after running the training that the synaptic weights changed quite a bit. This is what we want in order to get our classifier to accurately predict new flowers. Now what he explains in his tutorial is that he is going to execute the predict command, and when he does so using the model that was just generated, the iris versicolor record, so class 1, is actually categorized as an iris setosa, so class 0. Because of this test, he doesn't expect the model to perform well on the test record, so he wants to revise it. Here we generate the classification report, so that confusion matrix. I'm going to go ahead and copy this over. Again, just put it at the very bottom, and let's rerun that. So after rerunning, you can see the confusion matrix here. We have the precision and the recall, as well as the overall accuracy of the model. So this is not very good. We also have some warnings here, but that's perfectly fine. If we scroll to the bottom, you can see what we would like. We would like the precision and recall scores to both be 1, which would mean that all of the test records were classified correctly. So what we're going to do is change a little bit of the code in order to improve the model, and we're just going to use 3 variables. So I'll show you how to alter the code accordingly. If we scroll back up, what we're going to do on line 42, I'm going to change where it says random to 3, 1, and then up here I'm going to eliminate this 0 on line 23. Let's run it again. And here you can see that we got the results that he got. So precision and recall of 1. This means that we were able to accurately predict every single class of the flowers that were in the testing set. So we could report this result and that would be a very good result. And there was no funny business here. We didn't overtrain the model or anything like that. We were able to simply train the data in a neural network, revise as needed, and then get our report. This has been an introduction to neural networks and a little bit of Python in the Google Colab tool. If you have any questions about this, please let me know.